Hello, my name's Georgia White, and this digital presentation explores an investigation conducted within a biological sciences unit. The investigation explores the way in which living things grow, change, and have offspring similar to themselves, all within a Year 2 classroom context. The investigation will involve a fair test when growing sunflower seeds. In order to approach this inquiry activity, I formulated an investible question which is linked to the real-world context or to children's interests. Pursuant to Chapter 1 of Keith Stamp's book, Teaching Science Constructively, primary students enjoy science more when it is student-centred. Their voices are heard and there is a focus on investigation. I use this knowledge to form my investible question, which asks, how long does it take for a sunflower seed to sprout when the amount of water given is changed? The approach taken to conduct this investigation will involve a fair test in order to ensure the variables that are changed are directly affecting what is being measured. The independent variable which will change throughout the investigation will be the amount of water used. The dependent variable that will be measured will be the height of the plant tracked over a 5-week period. There will also be many controlled variables, which will always remain the same throughout the course of the investigation. These include the time of planting, the place of planting, the place the plant is kept, the amount of sunlight the plant is exposed to, the equipment used to plant, the time of watering each day. The resources needed to carry out this investigation include 2 plastic cups, soil, gardening gloves, fresh water, sunflower seeds, a measuring cup, and a clear area to place the seedlings, which will get direct sunlight during the day. The method requires both cups to be filled halfway with soil. Once filled, using one finger, a small hole should be formed in the centre of the soil in each cup. 2 sunflower seeds should be then placed into each hole. Once placed, soil should then be pushed to cover the seeds. 2 centimetres of water should be poured into the measuring cup, which will then be poured directly onto the seedling. 0.5 centimetres of water will then be added to the measuring cup, which will then be poured onto seedling 2. Both plants should be placed in a spot which will receive a prolonged period of direct sunlight during the day. This investigation provides many strong links to the Australian curriculum, as well as fulfilling the obligations of the Year 2 Biological Science Understanding Content Descriptor. It also explores science as a human endeavour and science inquiry skills. When looking at science as a human endeavour and science inquiry skills, this investigation involves observing, asking questions, and describing changes in objects and events. This can be fulfilled during and after the fair test is carried out in order to engage these skills. As well as fulfilling the obligations of the Australian curriculum, this investigation also allows for easy links to integrate general capabilities such as literacy and numeracy and cross-curriculum priorities. This investigation can easily engage students' literary skills, as they can be encouraged to write out the method and answer inquiry questions about their findings. Numeracy skills will also be utilised throughout the data collection and analysis process, as it is required that results are recorded and then compared using a graph. When looking at cross-curriculum priorities, Aboriginal and Torres Strait Islander histories and cultures can be acknowledged within discussions about the task. This investigation leaves room to explore the Aboriginal and Torres Strait Islander connections to land and discuss key histories and cultures. Technology is also easily integrated into this investigation during the analysis process, allowing students to present their findings virtually using ICTs in order to create their graph. The investigation was run over a 5-week period and provided very unique and easily comparable data. Plant 1 was only receiving 0.5 centimetres of water each day, which was clearly reflective within the results, as the plant only reached the height of 8 centimetres by the time the 5-week period was over. Growth of the plant has a noticeably slower start within the first 2 weeks, when most leaves start appearing within the 3rd week mark. After this period, growth seemed to slow down up until the 5th week. In comparison to this, plant 2 proved to be thriving. This plant was receiving 2 centimetres of water each day, which was also reflected within the results. On the 3rd day after planting, it was already clear that the plant was thriving as it was beginning to sprout. In order to represent this data in a way that was easily transferable to a Year 2 student, I decided on clearly labelled coloured bar graphs. Colours are key to be used in this situation, as the Year 2 age group will really resonate and engage with this. Pursuant to Scootle, this age group will be getting introduced to data representation and interpretation during their numeracy lessons. Therefore, colours and pictures, if possible, are key to ensuring their understanding of this data display. As can be seen by the side-by-side comparison of these 2 graphs, the independent variable had a clear impact on the dependent variable. At the 5-week mark, plant 1, which was only given 0.5 centimetres of water each day, had only reached 8 centimetres, while plant 2, which had been given 2 centimetres of water each day, had reached 11.5 centimetres. This investigation has the potential to light a spark in students to begin connecting with the biological sciences substrand on a deeper level, and begin considering how living things grow, change, and have offspring similar to themselves. Specifically, students will discover that living things have predictable characteristics at different stages of development. Through this investigation, children will begin to understand the life cycles of a plant and how its needs have to be met in order to grow and develop. Key understandings that students will take from the lesson include the understanding that the life cycle of a plant is multi-generational and that the process begins with the germination of a seedling, as shown to them. As well as this, students will learn that water, time, oxygen availability, and light exposure are all key to the germination process. The key understandings formed through this investigation allow a foundational structure of biological substrand to form and provide an opportunity to understand big ideas of biological sciences. Namely, students will understand interdependence of organisms in the environment. They will also understand the adaptive function of structures and the behaviour of living things. As well as this, they will understand the biodiversity, change and continuity that categorise any ecosystem. Pursuant to Scamp and Preston, understandings formed through investigations such as this one allow a broader knowledge base to form, aligning with other aspects of the biological sciences. Ideas about living things, representations and learnings of animals and their behaviours, life cycles, food, energy and habitats. When carrying out an investigation such as this in the classroom environment, many considerations need to be made in order to ensure the safety of all students and a smooth process throughout. These considerations could include a risk assessment of possible consumption of materials by students, access to clean running water, and limitations to access of necessary supplies. Other considerations need to be made about how to best engage all students and differentiate certain parts of the investigation to ensure the experience is fulfilling for all students. Examples of this include a tiered approach to ensure students at a high and low level can both engage collaboratively and interactively. Another strategy is to allow students to record data using ICTs or manually in their books if they choose. As outlined by Roth, carrying out investigations with primary students allow them to understand how scientific inquiry can explain the world. It allows them to compare and relate with the learnings of their own lives and allows them to build a number of other vital skills which are transferable throughout their education. These skills can include the ability to describe their investigations, identify limitations within their investigations, and develop reasoning and generate possible factors to explain their findings.
It is clear from this discussion that investigations in primary science are extremely important for a student's learning. Thank you for listening.